Imagine giving a piece of like newly written software, your company's corporate credit card, right?
Yeah.
And administrative access to your entire network.
Mm.
And you just give it instructions to, figure it out.
Oh, wow. Yeah, that sounds terrifying.
Right. And then you leave it completely unsupervised for 7 days.
Just a recipe for absolute disaster.
Exactly. It sounds completely nuts. But welcome to this deep dive. Today, we're looking at the July 16th through 31st, 2026 Google Cloud Technology Nuggets. And we're going to explore how Google Cloud is actually making that 7-day autonomous run a reality.
And making it secure enough that you can actually sleep at night.
Yes, exactly. Because our mission today for you, the listener, is to kind of cut through all that AI marketing hype, right? We want to look at the actual practical updates that Google Cloud Platform or GCP practitioners really need to know.
Yeah, because we are officially past the era where AI was just, some shiny prototype you showed off in a boardroom. We're in the trenches now.
We really are. And just to set the rules here, since you might be a beginner or intermediate GCP user, we are going to avoid the heavy technical jargon. We'll briefly explain what these GCP products actually do before we get into the updates.
Which is super important because running these systems at an enterprise scale introduces some very real, very messy infrastructure challenges.
Totally. And we're going to cover a lot, from databases that intelligently translate languages on the fly to cost-saving mechanisms that literally put your serverless infrastructure into cryogenic sleep.
Which is, honestly, one of my favorite updates.
Oh, so cool. But let's start right at the application layer with the stars of the show, right? AI agents, specifically the Gemini Enterprise Agent Platform.
Right.
And just to set the baseline for everyone, this is GCP's suite of services designed specifically for building, scaling, governing, and optimizing AI agents. Okay, let's unpack this.
So the marquee update here is what you alluded to at the very beginning. Agent runtime within this platform now supports running multi-step agents continuously for up to 7 days.
7 days? Wait, let's really think about that for a second. If I let an autonomous script run for a week, what is stopping it from, getting stuck in some infinite loop, hallucinating a bunch of garbage, and racking up a $100,000 cloud bill while I'm on vacation?
I mean, that is the exact nightmare scenario every cloud architect worries about.
Right.
Because previously, keeping a continuous, coherent thread going without the agent just, losing the plot completely was the main bottleneck.
Yeah.
But Google has paired this extended runtime with a new architecture called the Agent Memory Bank.
Okay, walk me through how that actually works under the hood. Because honestly, an AI agent used to be sort of like a goldfish with amnesia.
That's a great way to put it.
You tell it to do something, it would execute one step, and then completely forget its underlying motivation.
Exactly, because it was just relying on whatever fit into its immediate context window. But the Agent Memory Bank fundamentally changes that. It uses these structured schemas to extract and maintain context across interactions.
Oh, so it's not just holding a massive block of text.
No, not at all. Instead of just trying to remember a massive transcript, the system actively extracts key entities, user intents, and completed milestones, and stores them in a structured format.
Okay, wow.
So it's no longer a goldfish. It operates more like a dedicated employee who takes meticulous notes, remembers your overarching goal from last week's meeting, and, works over the weekend to systematically check off the subtasks.
Okay, that makes sense. That covers the memory aspect. It remembers what it's doing. But, it still doesn't fully answer my concern about security.
Sure.
Because 7 days is an absolute eternity in compute time.
Yeah.
If it goes completely rogue on day 3, the damage is already done, right?
Well, if we connect this to the bigger picture, that brings us to the governance layers that just have to be built around this. You can't have a 7-day runtime without transitioning security from an afterthought to a foundational layer.
But it has to be preventative.
Exactly. And this is why they introduced Agent Gateway. Think of it as a centralized choke point for access control. It sits right in front of the agent and provides inline, real-time protection against things like prompt injection and tool poisoning.
So wait, it's actively policing the inputs before the agent even gets a chance to process them?
Yes. It uses a feature called model armor to actively filter the inputs and outputs. So if a bad actor tries to, trick the agent into exposing sensitive data or executing a malicious script.
Which happens all the time.
Right. Model armor identifies the anomalous pattern and just blocks the interaction entirely. And furthermore, they've introduced agent identity.
Oh, okay. Now, identity and access management, IAM, is basically the master control system in GCP, right? It lets administrators authorize exactly who can take action on specific resources. How does agent identity play into IAM?
It binds those specific IAM permissions directly to the agent's runtime.
Oh, wow.
Which is crucial for accountability. It creates this non-repudiable audit trail. You aren't just guessing how a file got modified. You have a cryptographic receipt showing exactly what permissions that specific agent had when it made a specific move.
That's huge.
Yeah, and when you combine that with CodeMender, which automatically scans and remediates code vulnerabilities, and the new agent registry for cataloging all these agents globally, you realize you aren't just letting an AI run wild.
Right.
You are confining it to a heavily monitored, meticulously controlled sandbox.
Okay, that makes me feel a lot better about the 7-day leash.
Yeah.
But if an agent is taking meticulous notes and remembering complex goals for a week, I mean, it needs a massive, robust place to store and query all that data, right?
Absolutely.
It needs a serious data foundation. And in the Google Cloud ecosystem, when you talk about massive data foundations, you are basically talking about BigQuery.
Yep, the heavy hitter.
Right. Which, for our listeners, BigQuery is GCP's fully managed serverless enterprise data warehouse. It's built for processing massive scale analytics. And usually when you talk about BigQuery, you also talk about Looker, which is GCP's enterprise platform for business intelligence.
Right. They go hand in hand.
Yeah. So I saw an update in these nuggets regarding BigQuery that I know is going to make data engineers breathe a massive sigh of relief. It's in the Jupyter Notebook workflow, introducing something called the %QSQL IPython cell magic.
Yeah, the name sounds a bit esoteric, I'll admit, but it solves one of the most frustrating bottlenecks in data preparation.
Ooh, tell me about it.
Data engineers are constantly caught in this tug of war between two different worlds. You have Python, which is great for manipulating complex data frames locally, and then SQL, which is just the undisputed king of querying massive data sets in the cloud.
Right. Usually, if you have data in a local Python pandas data frame and you want to join it with a massive table in BigQuery, you have to serialize the data, upload it, write this cumbersome external pipeline, and then pull the results back down.
It's awful.
It is so slow and expensive.
It creates immense friction. But with this new update, developers can use the BigQuery DataFrames library to query their local pandas data frames directly using the BigQuery SQL engine.
It's like finally getting the two smartest people in the room, Python and SQL, to just speak the exact same language without needing a slow, clunky translator in the middle.
That's a perfect analogy.
Because under the hood, it just converts the local data to temporary tables on the fly, runs the massively parallel SQL query, and drops the results right back into your workflow.
Yeah, building hybrid data pipelines just becomes completely frictionless. But, BigQuery isn't just for preparing the data the AI needs. It's now essential for monitoring what the AI actually does.
Interesting.
GCP has added the ability to route Gemini conversational telemetry directly into BigQuery log router syncs.
Okay, let's pause there for a second. When we say conversational telemetry, what exactly is being routed and stored?
We're talking about the raw materials of the AI interaction. The actual prompts the users are submitting, the specific foundation model the agent chose to use, and, this is key, the underlying reasoning the model generated to arrive at its conclusion.
Wait, so if an agent makes a decision that negatively impacts a customer, you aren't just left shrugging your shoulders. You can actually query BigQuery and say, show me the exact prompt and the exact chain of thought this agent used on Tuesday at 4 p.m.
Precisely. By routing this continuous cloud logging alongside your standard administrative audit events, you get a single pane of glass for user activity and control plane telemetry.
That is massive for compliance.
Exactly. In a highly regulated enterprise, keeping track of why an agent made a choice is legally and operationally just as important as the choice itself. You have to have the receipts.
And speaking of receipts, I noticed the Open Knowledge Format, or OKF, has moved to version 0.2. They added a new concept type called attested computation. How does that fit into this idea of accountability?
Attested computation provides a mechanical cryptographic way to verify if a value was actually computed using sanctioned approved queries.
Okay, so a guarantee, basically.
Right. Before a downstream application trusts a piece of data, it essentially checks the execution receipt against declared parameters. It proves that the data wasn't tampered with or, generated by a hallucinating model. It was derived legitimately.
It's basically a trust but verify model built directly into the data layer itself.
Exactly.
We also saw that conversational analytics is now generally available for BigQuery and Looker, letting practitioners essentially chat with their data to generate insights without writing complex SQL.
Super helpful for accessibility.
Yeah. And the SAP Business Data Cloud Connect for BigQuery is also GA, which is huge for enterprise users. It offers zero-copy querying of SAP tables, meaning you can analyze your core business data without the cost and risk of physically moving it around.
Which highlights a much broader theme here, leaving data where it is and bringing the intelligence directly to the data.
That's a perfect pivot, actually.
Right.
Because BigQuery handles all the massive historical analytics. But what about the operational databases?
Right.
The databases that are actually serving your live applications and actively communicating with these agents in real time.
And this is where we see probably the most significant friction point in the entire industry right now. Google's recent State of Infrastructure report revealed a pretty staggering statistic.
Oh, yeah.
83% of organizations acknowledge they need immediate infrastructure upgrades specifically to handle production-grade agentic AI.
83%. Like, if you are a practitioner listening to this right now, think about your current stack. If your company rolls out an ambitious AI agent tomorrow, your operational database is overwhelmingly likely to become the immediate bottleneck. Why is that?
Well, the report points directly to a lack of high-throughput vector databases. Traditional databases were built to retrieve exact keyword matches, right?
Exact text.
But AI relies on vector search, which retrieves concepts based on mathematical similarity, and that is incredibly compute-intensive.
Okay, enter AlloyDB. Now, for those newer to the ecosystem, AlloyDB is GCP's fully managed PostgreSQL-compatible database. It's custom-built for highly demanding, top-tier enterprise workloads. So how do they solve the vector bottleneck here?
They introduced a columnar engine accelerated HNSW, which stands for Hierarchical Navigable Small World.
Okay, let's break down that mechanism. Why does HNSW make such a huge difference?
Well, instead of scanning every single vector in the database to find a similarity match, which takes forever,
Right.
HNSW builds a multi-layered graph. It navigates through these layers, quickly zeroing in on the neighborhood of relevant vectors without scanning the entire dataset.
Oh, that's smart.
Yeah, and by accelerating this with a columnar engine and AlloyDB, they're seeing up to 4 times higher queries per second and significantly increased recall precision compared to standard PostgreSQL PG vector. It makes the AI short-term memory retrieval blisteringly fast.
Here's where it gets really interesting, though, because the vector search wasn't even the update that surprised me the most. I want to talk about how they solved the language processing issue, because this is wild.
Oh, yeah, this is a great one.
Traditional PostgreSQL text search parsers rely on whitespace. They literally look for the spaces between letters to figure out where a word begins and ends.
Which works totally fine for English or Spanish.
Right. But it completely breaks down when you are dealing with continuous logographical languages spoken by billions of people, like Chinese, Japanese, and Korean.
Yeah, there are no spaces.
There are no spaces. Historically, if you wanted to search that text intelligently, you had to export your data out of the database, run it through some heavy, expensive external natural language processing pipeline just to segment the words, and then ingest it back into the database.
It's just a fragile, slow, and expensive architectural anti-pattern.
Exactly. But now, developers can use native Gemini AI functions directly inside their AlloyDB SQL queries. There's literally a command called a.generate. The database just natively asks Gemini to perform intelligent word segmentation and stop word removal on the fly, without the data ever leaving the database.
What's fascinating here is how this reflects a profound shift in database architecture. For decades, the paradigm was extract the data from the database, process it in the application layer, and load the results back.
Right.
By pushing AI processing down into the database layer, you eliminate network latency, you drastically cut compute costs, and you reduce your attack surface because the sensitive data never moves.
Okay, so we've covered the application layer with our 7-day agents, and the data layer with BigQuery and AlloyDB. But eventually, this code has to live somewhere, right?
It does.
If 83% of companies need infrastructure upgrades, how do you actually deploy this at scale without breaking your network or, getting an angry call from your CFO about a catastrophic cloud bill?
That brings us directly to the compute layer. Google Kubernetes Engine, or GKE, and Cloud Run.
Okay, quick definitions for everyone. GKE is GCP's managed environment for running containerized applications. It basically orchestrates all your little software packages so they run smoothly.
Right.
And Cloud Run is GCP's serverless platform, meaning you just hand it your code and it runs without you ever having to provision or manage a single server.
Exactly. Now, the underlying challenge with moving from prototype to production is managing the unpredictable nature of AI traffic. The Nuggets highlight a fascinating case study from YouTube on how they build a specialized AI prototyping stack to handle this safely.
This was brilliant. YouTube realized that rapid enterprise AI prototyping often fails because of strict corporate network rules. I mean,
Yeah.
you can't just give an experimental, unpredictable AI agent access to live production databases.
No, absolutely not.
So they completely decoupled the data layer. They used a Google Cloud proxy server to give the AI authenticated but strictly read-only access to live metadata.
It creates a physical and logical barrier. The AI gets the real-time context it needs to test its logic, but it is architecturally impossible for it to accidentally delete a production table or corrupt live data.
Which allows developers to move fast without breaking things.
Exactly. But once you move that agent into production, you run into the cost problem.
Right, the cloud bill.
AI workloads are notoriously bursty. An agent might spend 3 seconds processing a complex request and then sit idle for 10 minutes waiting for the user to reply. If you are paying for premium compute resources for those 10 idle minutes, you are literally just burning money.
Which is why the GKE Agent Sandbox is such a critical update. They're utilizing a technology called gvisor Sentry to heavily isolate these containerized agents, allowing them to safely pack up to 88 active agents onto a single node. But the real magic is how they handle the idle time.
Yes, the pod snapshots.
Walk us through the mechanism of how this actually saves money, because this is so cool.
When an agent goes idle, GKE can take a snapshot of the pod's entire state and serialize it to persistent storage, essentially saving it to a disk. It then completely frees up the CPU and RAM that the agent was occupying.
Wait, so it's basically putting our AI agents into cryogenic sleep.
Basically, yeah.
You freeze the agent, stick it in storage, and stop paying for the expensive RAM and CPU. And then, when the user finally replies 10 minutes later,
GKE instantly rehydrates that snapshot from the disk back into memory, and the agent picks up exactly where it left off, in milliseconds. You optimize your compute density drastically because you are only paying for the exact microseconds the agent is actively thinking.
that is an absolute game changer for anyone managing a cloud budget. Now, what about Cloud Run? For the teams utilizing a fully serverless approach, what are the updates there?
Well, Cloud Run has received a major update to its multi-region high availability capabilities. In enterprise environments, if an entire cloud region experiences an outage, you just cannot afford downtime. Cloud Run now uses advanced readiness probes to run continuous instance-level health checks.
So no more waking up to a pager at 2 a.m. because a region went down and traffic is dropping into a black hole.
Exactly. If it detects a failure, it utilizes global external application load balancers to seamlessly redirect public traffic to a healthy region within seconds. For internal east-west traffic, meaning the traffic moving laterally between your own microservices, it leverages cross-regional internal load balancers.
So the infrastructure is effectively healing itself.
Exactly.
But all of this highly available agent-driven infrastructure brings us to our final, and arguably most important, focus area. Locking the doors.
Security at the perimeter and within the network, it's vital.
Right. We've built this massive system, but we have to ensure that only the exact right people and the exact right AI agents can access it. We mentioned Cloud IAM earlier, Identity and Access Management, as the master control system for authorizations in GCP. How is IAM evolving to handle this new AI workload?
Well, one major quality of life update is for AlloyDB. In preview, they've introduced IAM group authentication, because previously managing individual database user credentials at scale was an absolute nightmare for security teams.
Oh, I can imagine, especially if you have hundreds of autonomous agents spinning up and down all the time.
Exactly. Now, you can manage access for up to 200 functional Google groups. You assign the permissions to a group, and just add or remove agents or human engineers from that group. It unifies security policies across AlloyDB and Cloud SQL instantly.
So what does this all mean for practitioners? Because they also expanded IAM conditions, which I find incredibly practical. You aren't just granting broad access anymore. You are granting attribute-based restrictions. It's like a head chef in a busy kitchen telling a sous chef, you have permission to use the expensive truffles, but only during the Friday dinner rush, and absolutely not for the pastry menu.
That's a really good way to visualize it. That level of granularity is vital. You can say, this engineering group has access to query this specific database, but only on weekdays between 9 a.m. and 5 p.m., and only if they're connecting from a corporate IP address.
The Nuggets also detailed several security blueprints, specifically for GKE. And there was one mechanism in there that I want to unpack. K8S IBOM.
Ah,
It
yes.
stands for Artificial Intelligence Bill of Materials. Why does a cloud practitioner need a bill of materials for their AI?
Well, think about how an AI model is constructed. It isn't just a single file you write from scratch.
Right.
It relies on hundreds of open-source Python libraries, external dependencies, and third-party frameworks. If a bad actor compromises just one obscure open-source library on GitHub, and you pull that into your infrastructure to run your AI, your entire network is compromised from the inside. This is a classic supply chain attack.
Ah, okay, so the AI bomb is a defensive mechanism against that.
Yes. It generates a comprehensive cryptographic receipt of every single ingredient, dependency, and software version used in your AI deployment. It maintains complete supply chain visibility.
Oh, that's smart.
Yeah, if a vulnerability is discovered in a specific library a month from now, you don't have to guess if you are exposed. You check your AI bomb, pinpoint exactly where that library is running, and isolate it instantly.
And when you combine that with confidential nodes, which, by the way, use specialized hardware to physically encrypt the data while it is sitting in the GPU and TPU memory, you start to see a very hardened perimeter.
This raises an important question, though, about the future of security, because human manual firefighting is simply no longer sufficient.
What do you mean?
When you are deploying agents that can run for 7 days and operate at machine speed, human reaction times are irrelevant.
Oh, wow.
This was a major focus in the recent Cloud CSO Perspectives newsletter, highlighting the Google AI Threat Defense Platform, or ATD.
We have to fight machine speed threats with machine speed defenses.
Exactly. ATD transitions Security into an automated, continuous capability. It combines the reasoning capabilities of the Gemini model, the deep cloud visibility provided by Wiz, the automated code remediation of CodeMender, and the frontline threat intelligence of Mandiant into one unified architecture.
Wow.
Yeah, if an anomaly is detected, the system doesn't just send an alert to a dashboard. It reasons through the threat, quarantines the affected resource, and generates the remediation code automatically.
Okay, let's take a breath and look back at the journey we've just been on. We started by exploring how to build AI agents that can securely run for 7 days straight without losing context, thanks to the agent memory bank.
Yep.
We fueled them by routing their telemetry into BigQuery for full accountability and gave them intelligent native language processing capabilities directly inside AlloyDB vector searches. We scaled them efficiently using GKE's cryogenic sleep to save massively on compute costs, and we locked the entire ecosystem down with granular IAM conditions and automated threat defense.
It provides a very clear, actionable roadmap for the modern enterprise cloud architect. But, if we step back, it leaves us with something quite profound to consider regarding our own roles in this industry.
What do you mean?
Think about the trajectory of the technology we just discussed. If our infrastructure can now automatically freeze and thaw containerized applications to perfectly optimize our billing, and our databases can natively ask an AI to translate and segment languages without us ever having to write or maintain a data pipeline, how far away are we from the infrastructure essentially writing and managing itself?
Oh, wow. That is, yeah.
Right. Will the future GCP practitioner even need to write infrastructure as code? Or will your role transition away from being a traditional engineer, leaving you to act almost exclusively as a high-level manager overseeing a highly capable digital workforce?
That is a deeply fascinating thought to leave on. Are we building the infrastructure, or are we simply managing the digital employees who build it for us? We want to thank you so much for joining us on this deep dive into the Google Cloud technology nuggets.
It's been great.
Yeah. And if you want to get hands-on and actually build some of this yourself, the source material links out to a fantastic blog post covering 13 different demos and code labs specifically for the Gemini Enterprise Agent Platform. We highly recommend you go experiment with those. Until next time, keep exploring, keep questioning, and we will see you on the next deep dive.